As we saw in the previous part of the lesson, we saw that there's more than one way to represent a polar coordinate. In fact, there's an infinite number of polar representations of r theta. Let me actually just write that. There are an infinite number of representations of any polar coordinate, and this makes sense because we are working with angles. And as we saw, there are an infinite number of coterminal angles. So in general, and I'm not sure what's going on with my pencil. Let's try that again. So in general, we can say the following. We can represent some polar coordinate, like r theta, as the following. We can just say, all right, let's use the same r value, but just come up with any coterminal angle. So let theta plus 2 pi n, for example. So any angle, and just find its coterminal angle. And boom, you've represented or found another polar coordinate that is in the same spot. What you could also do is you could use the opposite r value or the negative r value, but because that means we're reflecting it over the pole, what we're then going to have to do is find a way to deal with that angle as well. So we would say theta plus, and ask yourself, what would I need to do to make sure that I'm coming up with not necessarily the coterminal angle, but an angle on the other side of the pole, which would be 2n plus 1 pi. Okay, so let's try a few examples of this. I've got another polar coordinate plane right over here. And again, there are my angles. And just like we did before, I'm going to want to go ahead and label my polar axis 3, 4, 5, and 6. And from there, let's look at our first polar coordinate that we are going to be plotting. So the directions say plot and label each point on the plane and find 3 other polar representations of each point. So we've got a couple of different representations here that we're working with. The first thing that I could do is just to find a coterminal angle of my angle 2 pi over 3. So the first thing I could do is say, all right, 1, and take my angle 2 pi over 3, and just add 2 pi to it. And that would then just give me 1 and 8 pi over 3. Do you see the issue here, however? This angle is not between the interval that was requested, so negative 2 pi, theta, and 2 pi. And if I don't give you any type of interval, then you're fine, you're dandy. But let's just say for the sake of this problem, we want to make sure that we practice working with angles that are specifically between negative 2 pi and 2 pi. So if we can't add 2 pi to our angle, our next logical option then would just be to subtract. And that would give me the following: 1, negative 4 pi over 3. And that is definitely between negative 2 pi and 2 pi. So I'm going to find negative 4 pi over 3, which would be right over here in the same spot as 2 pi over 3. And it has an r value of 1. So let's just keep that in black. And so where was I? There. And here is my point F. Okay. So now let's go ahead and try another way of representing that same coordinate. So since we've exhausted our options of just simply finding coterminal angles, now let's look at finding a negative r value. So since a negative r value reflects that over the pole, we then want to pretty much go ahead and find a way of getting ourselves to the same spot using our angles, which would just mean that we would want to add pi. So 2 pi over 3. And then add pi to that. And that would give me negative 1, 5 pi over 3. And let's plot that point. So 5 pi over 3 would be down here. And since we're dealing with a negative 1, that means I just want to reflect that over the pole. And boom, I'm in the same spot. There's my F. And then finally, let's go ahead and represent it in another way, negative 1. And this time I'm going to subtract pi. And that gives me negative 1, negative pi over 3. And if you just want to graphically check that, again, negative pi over 3 would be down here. ask yourself what that would look like with r being -1, and there we go, right in the same exact spot. So take a moment right now and pause this video and go ahead and try to do G on your own. So if you've tried G, first thing that you're going to want to do is you want to go ahead and take your angle and find a coterminal angle. And so we can go ahead and just try adding 2 pi. Since my denominator is 6, I'm just going to go ahead and just add 12 pi over 6 while I'm at it. And that gives me -4, 7 pi over 6. And that is between -2 pi and 2 pi. Then go ahead and try the other one. This time finding the opposite r value for -5 pi over 6 plus pi, or 6 pi over 6. And that gives you 4 pi over 6. And then finally, for -5 pi over 6, excuse me, minus pi, or -6 pi over 6. And that should give you 4 and a -11 pi over 6. So if you've done all that correctly, go ahead and check where G should be. So -5 pi over 6 would be coterminal with 7 pi over 6. Since it's -4, we should be right over here. And just take a moment and just check all your other points just to make sure that we're in the same exact spot. And we should be good to go there. Okay, so now that we're a little bit more comfortable plotting polar coordinates and finding different representations, let's go ahead and let's try some coordinate conversion. And for us here, what we're looking and essentially saying is we have a polar coordinate, which we're writing in terms of r theta. So r theta. What we want to do is we want to convert that into a rectangular coordinate, x, y. So how would we go ahead and do that? Well, let's take a look back at our original definition of what our polar coordinate was. So if we represent this point P in terms of its polar coordinate, so r theta, and you know what, let me just clean that up a little bit since my pencil is giving me some issues today. So r theta, and we want to express this in terms of x and y. And it looks like my pencil is really just not wanting to behave today. I'm not really quite sure what's going on. So we got r theta, x, y. We'll just go ahead and see if we can try that. What do we know in terms of all of these? Well, we know that this is our angle theta. We know this is our r value. And for this point P, we also know that this gives us our y value, while this here represents our x value. And just ask yourself, what do I know of that might be able to connect my x and y with my r and theta? And that sinking feeling that you have in your stomach right now, that's trigonometry. Because we can say easily that cosine of theta is equal to x over r, or adjacent over our hypotenuse. Sine of theta would be y over r. So we can rewrite these and say the following. We can say that x is equal to r cosine theta, and y is equal to r sine theta. Well, if that is the case, then if I just go ahead and rewrite that over here, so let's take that, and take this as well, we can then say the following. Our polar coordinate, r theta, can then be written as r being equal to a way of getting to x and y. So what is x equal to? Well, x is equal to r cosine theta, and y is equal to r sine theta. In other words, if you're given a polar coordinate and you know your r value and you know your theta value, simply finding r cosine theta will then give you your x. And if you know your r and your theta, finding r sine theta is going to then give you your y. And you can take that polar coordinate and then rewrite it in rectangular form. What if I wanted to go the other way around? What if I want to go from rectangular to polar? Well, if I wanted to say, all right, given my x and my y, I want to find what my r and theta is, I'm using my same trigonometric identities. But some other ways to generalize this to make this a little bit more useful is to again ask yourself, what relationships do I know between x and y, and specifically r? We could say the following. We could say x squared plus y squared is equal to r squared. And again, that's just the Pythagorean theorem in action here. X squared plus y squared is equal to r squared. And you'll notice that we've used sine and cosine, but there's nothing saying that we can't also use tangent here. So we can say tangent of theta is equal to y over x. So tangent of theta just being our opposite over our adjacent. Okay. Now, if that is the case, we can take any xy value. If we're given our x and y value, we can say the following. Well, x can really just be some way of getting to r and theta. So ask yourself, if I know my x and my y, how can I figure out my r? Well, since x squared plus y squared is equal to r squared, just move that over here, that means r is equal to the square root of x squared plus y squared. So we can then say x squared plus y squared, or the square root of this quantity, that's our r value. And theta, well, theta would just be theta. And how can I figure out theta? You're going to want to use tangent of theta. And this will make more sense when we start doing some examples of this down below. So I'm going to leave this up here as I go through some of these problems. So let's practice converting some coordinates from polar to rectangular. So the first three problems here are polar coordinates. They give us our r value. So let me just write this. Our r value is equal to 2, and our theta value is equal to pi over 3. So given this information, what do we know? How can I convert this into x and y? Well, looking back up here at our notes, we know that x is simply going to be equal to r cosine theta. So I'll write it out since it's our first time doing this. X is equal to r cosine theta. That means 2 times the cosine of pi over 3. Now I know it's been a while, but try remembering your unit circle or your trigonometric identities or your trigonometric anything. 2 times cosine of pi over 3 would be 2 times 1/2, which is equal to 1. Now, what about our y value? Y is equal to r sine theta. So if r is equal to 2 sine of pi over 3, that would then just give me 2 times root 3 over 2. So our final coordinate would just be our x is 1 and our y value is root 3. So there's our polar coordinate there. Let me go ahead and box that. Okay. So take a moment, pause the video, and try the next two on your own. Just really practicing converting polar coordinates to rectangular coordinates using the identities above. So hopefully you've given these a shot. So let's go through them. Again, we know our r, we know our theta. Our x is always just going to be 4, or r times cosine of theta. So 4 times cosine of pi over 2. And we're going to go 4 times sine of pi over 2 to figure out our y. That would give us 4 times 0. And this is 4 times 1. So my coordinate would just be 0, 4. And if you haven't already done so and started thinking about these coordinates, go ahead and plot 4 comma pi over 2. This polar coordinate, plot this on a polar plane right now. And then go ahead and plot the point 0, 4 on a rectangular plane and ask yourself, what do you notice about the two? Now, finally, let's go ahead and do the last problem. We've got -3, our r value times cosine of theta, times -3 sine of theta. And if we just evaluate those, we should get -3 times -√2/2. And -3 times also √2/2. Or no, this time would be positive √2/2. Because we're in quadrant 2. And that should give us 3√2/2. -3√2/2. And there's that. That didn't go exactly the way that I had hoped. Let's try that again. Okay. All right. Now let's try going the other way. Let's go from rectangular to polar coordinates. So this time we are given our x and our y value, and we're trying to figure out our r and our theta from this. So first off, let's try to figure out our r. We know our r is going to be the square root of x squared plus y squared. And again, reference your notes from above. Well, we know our x and our y, so -1 squared plus 1 squared. So r is simply equal to √2. Now, for theta, to figure out our angle, we can say that the tangent of our angle, whatever it might be, is equal to y over x. So in this case, tangent of theta is equal to 1 over -1. So using your inverse trig functions, ask yourself, what is the arctangent of -1? Now, keep in mind that this is only going to give us an angle between -π/2 and π/2 if you're using inverse trig functions. But think about where this point -1, 1 is. Think about this. -1, 1, that rectangular coordinate is over here in quadrant 2. So if we're only given if we're doing the arctangent of -1, let me write that. Arctangent of -1, and that gives us an angle down here. Specifically, it gives us -π/4. Ask yourself, what would I need to do to make sure that I end up in quadrant 2? Well, I'd want to add pi to my angle theta. In other words, we can say that since this gives us -π/4, I want to make sure I add pi to that so that I'm in the same spot that my actual rectangular coordinate is. So theta would turn out to be 3π/4. So we always have to keep that in mind. Ask yourself, where is my original rectangular coordinate? What do I need to do given the restrictions or the range restrictions I have with my inverse trig functions? Just to finish this up, my r value is √2. My theta is 3π/4. And there's my rectangular coordinate. So again, pause the video right now and try the next two. So for this next one, since my point is at -2, 0, I'd like to actually do this at the beginning of most problems. Right away, just by seeing where my rectangular coordinate is, this actually makes a couple things kind of easier. Right away, what is my, I don't even actually really even do any math here, or I would say calculate anything. What is my distance from the pole? R is equal to 2. In other words, I have a distance of 2 from the pole. What would my angle theta here be? Theta, in this case, would be simply equal to pi. Now, you could do the inverse tangent, and you could go ahead and calculate r is equal to the square root of the quantity of x squared plus y squared. But just by graphing -2, 0, I can see pretty easily that my polar coordinate is simply 2, pi. Okay. And finally, 3, -√3. If I were to graph this one, I would say that this would be 3, and -√3 would be somewhere down here. And this one, we are probably going to have to do a little bit of calculating, but it's not too bad. We know, again, r is equal to the square root of x squared plus y squared. So 3 squared plus negative root 3 squared. So r is equal to root 12. And if I simplify that, that's 2 root 3. We know that theta is equal to the arctangent of y over x. So in this case, negative root 3 over 3. And again, that should give us an angle in quadrant 4, which works out pretty well for us. It's going to specifically give out theta. If we just use the inverse trig function, that's going to give us negative pi over 6 or negative 30 degrees. But since we typically want to express our angles from 0 to 2 pi, we could just also write this as 11 pi over 6. This is not absolutely mandatory, but if I gave you some type of interval restriction, you'd want to do that. You could also write as negative pi over 6. And then say my final rectangular coordinate, or polar coordinate, excuse me, is 2 root 3. There's my r value. And my theta is 11 pi over 6. And if you said negative pi over 6, that would totally be fine. There's absolutely nothing wrong with that at all. Okay? So hopefully this was helpful in you getting to understand how to plot our polar coordinates, but also understanding how to express polar coordinates in terms of rectangular form, their x and y values, and the other way around.